Okay, so in this lecture I'm just going to be doing some circuit analysis problems. It's going to be very short. There's only two problems, two very basic simple problems. So problem number one, part A. If the current that enters the terminal of an electrical element is 5 amps at t equals 0 seconds, what is the expression for charge transfer for t greater than 0 seconds? And then part B, use the expression from part A to evaluate how much charge will be transferred after 10 seconds. And so here's your circuit element. You have your current going into this terminal, and you have your voltage across those two terminals there. Okay, so current is defined as I equals dq dt. And so solving for Q gives us Q of t equals the integral between the limits of t and 0, I alpha d alpha. And so I alpha in this particular example is equal to 5. So Q of t is equal to our integral between the limits of 0 and t times 5 d alpha. And so now Q of t is evaluated a little bit more further, and now we have 5 times alpha between the limits of t and 0. And so Q of t is equal to 5t coulombs for t greater than 0. So that is our part A answer. And then next for our part B, the charge transferred after 10 seconds is Q of 10 equals 5 times 10 coulombs, which equals 50 coulombs of charge transfer. So that answers our B part of our question there. And so now for problem 2, the current at the terminal of an element is I equals 0 for t less than 0, and I equals 20 e to the negative 5,000 t for t greater than or equal to 0. Okay, so calculate the total charge transfer to the element terminal. And so that current is going to look like this. That is I of t there, and that's what it looks like. It's across a time span of 1 millisecond here, and that's what it looks like. It's a curve, okay? Exponential decaying curve. So first I'm going to use the fact that Q of t equals my integral between the limits of 0 and t with I alpha d alpha. And I alpha in this example, or in this problem, is 20 times e to the negative 5,000 alpha. Then Q of t equals 20 times our integral of e to the negative 5,000 alpha d alpha. And Q of t equals 20 divided by negative 5,000, and e to the negative 5,000 alpha is going to be evaluated between the limits of 0 and t. Then when we do that, we get this expression, and e to the negative 5,000 times 0, that is of course going to be equal to 1. So we end up with 1 there. And then to finish evaluating this, we want to take the limit of t as it approaches infinity of Q of t. And then when we do that, we end up with 20 over negative 5,000 times negative 1, and then that gives us 20 over 5,000, which is going to be equal to 4 times 10 to the negative 3 coulombs, and that gives us 4 millicoulombs. So that was the answer to our second problem, and this is what it's going to look like graphically. And so as you can see graphically, we have this curve approaching and converging at 4 millicoulombs, that is, because this is a graph of charge accumulation, and we can see that eventually it's apparent to us that it stops at approximately like 4 millicoulombs, but according to our calculation here, it stops at exactly 4 millicoulombs. So that is it. That is all that I have that I was going to cover, and so that completes this lecture. Thank you for watching. Hopefully it was helpful for you, and have a nice day.